So here's the first problem. Find the derivative of y equals 3 ln 14x. Okay? So what are we going to do?
14 over 14x.
Yes. Y.
You can think of it
U prime over
u prime over u. But we've got this 3 out here. So 3, what's u prime?
14.
Over. What's u?
So 14x.
So what do we end up with?
3 over x.
3 over x. Okay? All right? So if you'll just remember this, and you remember where your u actually is, you'll be okay. Is that good, Leland? Is it good? Yes? No?
How do you know which one is your
U is your argument, what you're taking the natural log of.
It's almost like a trick. It's too simple.
Yeah, that one's pretty easy. Enjoy. All right. Okay. Y equals ln of t squared. Okay, so what is u prime?
2t.
And now what?
It's 2 over t.
All right. We're not there yet. Okay, are we still there? Okay. All right. Yeah, that's why I didn't. Okay, this is actually theta. It looked like a 0, but okay. So what do we got here?
1.
U prime over u. So u prime is 1 over theta plus 9. Right? Okay. Oh, well, we like to start slow, right? All right, what would number 4 be? You guys do number 4. Yes.
So it's 1 because the derivative of the...
Theta was 1. Not the derivative of the constant, but the derivative of the variable, which was theta, is 1. Like the derivative of x would be 1. And the derivative of that part would be 0 of the 9. Okay? All right, so what do we get here? I hear you saying it, Lucas. Okay, you went all the way to the end. Okay. All right, what was the work in between for anybody that needed help with that? Okay. All right. Okay, this one, now we get a little bit of work because it's a product. Okay. All right, find the derivative for y equals x to the 5th ln x to the 6th. Okay? So first of all, you've got what going on? Chain. So we've got y prime is equal to 6 times this thing to the what? Times
Derivative of x 5 ln x.
Correct. Okay. Is this also a product? Okay. So what do we get? X to the 5th times, what's the derivative of ln x? Okay. Plus ln x times, okay. So what does this become right here? X to the 4th? I'll just kind of reorder that. Need more room. Okay, this is where your algebra can help you out. What happens with this? This is just a term. Can we raise this to the fifth power in here? Okay. Can we do it like that? Please, I don't know. Mm-hmm. Okay.
Why couldn't you do that to begin with? If that makes sense. Just take it to the sixth power and then get the derivative of it?
Which part? Oh,
The
here?
very first equation. But wouldn't that be easier?
You probably will end up with it. You do it. See what you get. That's what you get. All right, but we're not done. What should we get now?
Take out
What happens here? 6x to the what? 29th? Okay, so we multiplied this whole stuff times here, plus, now we got to multiply this times this. So what do we get? This piece times this. 30 x to the 29th, ln x to the what? 6? I think that's it.
Why do you have 30x to the 29th?
This piece times this part.
Entire thing.
Yeah, because you've got two pieces in here, and it's like you're distributing this guy with here and get this, and then with here and get this. Does that make sense?
Yeah, I thought. You're not just multiplying everything by 6. You're multiplying everything
By this whole
all
thing.
that.
Yeah. Yeah. Okay. All right. Okay, we good? All right. Sort of.
Well, I got,
Oh, did you finish?
yeah, I got 6x to the 29th plus 30x to the 29th ln x to the 6th. The only thing I didn't get was the ln x to the 5th.
You just forgot to put that with it.
I bet you just... I'm not sure where. I'll have to look at your work.
It's the product rule, so you just take x to the 30 times the derivative of ln x to the 6 plus ln x to the 6 times the derivative of
5. So that'll be 5x to the 4th in there.
Wait, what happens to the x to the 4th?
Well, the derivative of x to the 5th. I was just saying, so it'd be multiplying times 5x to the 4th at the end, right?
Because it's
Well, you said ln x times the derivative of x to the 5th, and the derivative of x to the 5th was 5x to the 4th. Did you account for that in that little...
what's this 6? So I had
Well, you're taking x1
to the power
like
30
if you put like if you multiply the x to the 25th times the ln x to the 5th, that's one term times 6. You got 6 25. Like just ignore the parentheses. Pretend like that's one term. Then the other one on the other side is the other term. So you just multiply that one by the first one and that one by the second one, and that's how you got your answer.
He's asking about
I'm just wondering why you wouldn't times that whole thing to x to the 4th. You get like 6x for the to the 29th ln x 5 plus.
You add the exponents when you multiply them. So like when you get 6x to the 25 times x to the 4th makes x
6x to 29.
Yeah.
ln x to the 5th. I don't know.
Oh, yeah, it is. It's all just like right there.
Okay.
I thought
Yeah. All right. We're not absolutely certain whether we just are missing a term or not. All right. Quotient rule? Okay. Let's try that. So, quotient rule, we're going to have 4 plus 3 ln x times derivative of ln x minus ln x times the derivative of 4 plus 3 ln x all over what? That thing squared. Okay. So we're taking two derivatives, here and here. Okay. So what do we get? We got 4 plus 3 ln x times 1 over x minus ln x times I have a no room. Okay. So over here, you can't really just cancel things out. You've got 4 plus 3 ln x over x minus 3 ln x over x. Does that make sense? And we did that because we got to combine those things up there. All right. So what happens? Those are gone. Okay. So we've got 4, and you just said it can just go to the bottom. I don't think there's much else we can do. Well, it's like you've got this. You've got 4 over x over this thing. So if you're dividing, you can put it down here. Or if you wanted to write it all out, you'd be saying 4 divided by x divided by this would be times 1 over that. And so then you'd still have it that way. But the shortcut would, be to say that. Okay? Questions on that one? Okay. Okay, this one's one you're going to do. Woohoo, I like that. I'll write it bigger. 3 plus ln t, make it x if you want, over 5 minus ln x. Okay? And you guys that have access to my notes, don't do it on paper. I want to see you work. Okay? Get some practice. You want some paper? You need some. Okay. It's very similar to the problem before. So if you use that technique, you should be fine. Is that what we got?
Yes.
Mitchell's excited. The thing that I would be concerned if you change it to X's on your paper and you're taking the test, you're likely to type it in that way. Just make sure, because there's no going back on a test. There's no, oh, I can just retype it. You're done. So if you're going to change the letter, just make sure that you put it in with the original variable. Yes, sir.
Before I forget, you said that online testing was put on like October 4th or 5th on those days? Is that Wednesday? Do we have to come to class on Thursday?
Yes. Because we're going on. We're starting chapter 4. But you don't have class the 13th, which is the following week.
Yeah, that makes me happy.
Happy or not, that's what's happening. Yeah.
All right, I had to ask because I was
Yeah, I got you. Okay, okay, see that negative 1 over x up there? And you've got minus and minus. So if you miss that, you'll miss the problem. Because you wouldn't get 8, you'd still have these things, it'd be crazy. Okay? Any other questions about that one? Okay. All right, I think the next one is that logarithmic differentiation one that I said that we would do about taking the ln of both sides. Do you remember doing that in college algebra?
Do what?
Taking the natural log of both sides when we solved. I know these guys that had me, like when you had e to the x equals 35 whatever, and you took that natural log of both sides to solve it.
That's when you did the log.
Well, you just knew that ln of e to the x was x, and so that was one way, but...
But argument was based. I don't remember how you actually did it. It was the argument. You did the argument from the...
Yeah. Okay, here's what this one looks like to start with, and it does have t's in it, so... All right, so that's y equals that. And so instead of doing the product rule and all of that, it says go ahead and take the natural log of both sides. So if we have ln of y equals, and then we're going to have the ln of that whole thing, and I'm not writing it again. Okay, all right. And then when you have it like that, the ln of all of that, we can break it apart into pieces. ln of t plus, it does look like it. And why can we do that? What's the logarithmic rules about products can be changed to? Do you remember that? Like if you have the natural log of AB, a product, that's equal to ln of A plus ln B. That's that product rule for logarithmic functions and that. Do you remember that? Okay, so that's what's going to happen here. This is a product. We have the log of it. So now we can break it apart and have, catch up with me, little pen, this. I'm running out of room. That looks ugly. And we've still got ln y over there. Okay? So that's your first step, and that's the approach that we're going to do. Then we're going to take the derivative of both sides. Okay? What's the derivative of ln y? 1 over y. We are taking this with respect to t. So isn't that implicit differentiation? 1 over y dy dt. Okay? Equals. And what is this one going to be? The ln of this? 1 over t plus 3. Okay? All right? Now, if I'm trying to find the derivative, what's the derivative? Isn't it dy dt? Okay? So I need to get rid of this. How do I get rid of 1 over y? multiply by y on the other side. So dy dt equals y times all of this.
They just
But we're not through. What were you going to ask?
they just stuck what y was in.
Yeah, because we know what y is. Y is right here, correct? So now we're going to have dy dt equals all of this stuff that's in yellow, t plus 3, t plus 3, t plus 6, times all of these. And so that's a multiple choice question, and it is this guy here.
Yeah, what goes in that box? What you just drew on?
This.
Oh, okay.
Okay.
That was not my question.
No, I was trying to do it where I didn't have to write, but if that's confusing, I will write. Sometimes that works. Does that make sense?
That's the answer.
That's the answer. It's it's all of this times those pieces there. Okay? So when you have this one, you're going to do it, take the natural log of both sides, use the algebraic rules for logarithmic things, and know that you can separate it into three things being added, not multiplied. Then you can take the derivative of each piece. It's not a product anymore.
Before you can, is that the format that it will fit on exactly?
Yes, well, it's a multiple choice question, so, but that is the right format.
Could there be a possibility that it isn't a multiple choice on the?
On your, I don't know about the test. I haven't made the test. If I do that on the test, I'll make sure either it looks like this or something, but I suspect it would be a multiple choice question.
So if you have like y equals t plus 3 divided by t plus 6, how do you do the natural log, do the minus?
Drew had a great question. He said, what if you had y equals a quotient? You could do the natural log of y equals the natural log, and then what happens with a quotient? How does it get separated? How does it get written? A subtraction. So instead of having to do the quotient rule, you would have two pieces with the natural log, and you'd do the same kind of idea. It might save you some. We didn't do that with that quotient rule. We went ahead and did it. But yeah, with logarithmic stuff, you can use those rules to help you out. Okay?
So what you're saying is instead of it being plus, those would have just been minus.
Yeah, like if we went here, could we do it here? Natural log of y equals the natural log of this, and when you expand it, you would have ln of 3 plus ln x minus ln of 5 minus ln x, and then you don't have a quotient. So that might work. Okay? It's a thought. All right. Find the derivative of, I don't know why these I guess I keep moving things. Okay, so we've got ln of 6 cosine to the 5th theta. We're supposed to find dy d theta. Isn't this u prime over u is what we're trying to do? What is the derivative of this thing? Well, 30 sine, negative sine, right? So negative 30, no, you don't put the sign there. What am I doing? We're not there yet. 30 cosine. Whoa. Sorry.
Does the ln go away?
I'm just doing the derivative part of this right now.
Okay.
Yeah. The ln does go away. Yeah. Because the derivative is 1 over that times the derivative of that. So what do we have? cosine to the fourth theta, and then times the derivative of that, which is negative sine theta. Does that make sense? Okay. And then that's going to be over 6 cosine 5 theta. And you would typically bring the negative in front. And could we...
Where did the negative sign come from?
Derivative of cosine is negative sine.
But why did you do that?
Chain rule. Because that fifth is there, but it's actually like being over here, and so it's 5 times 6 is the 30. Cosine, you take that theta, take one away, it's the fourth, and then times the derivative of that argument. Okay? What are we going to do here?
Where's your sign go? You brought the negative out, but you didn't.
You just so love to catch me, don't you? Right there. How about that? These are already written better than this, so that's cool. All right, so what are we going to do? What can we clean up here?
You can take cos 4 out. That's just cosine.
And what about the numbers? Negative 5 sine theta over cosine theta. And what is sine theta over cosine theta? Tan. So our final answer, absolutely.
What did you say happened to the LN?
Well, when you're taking the derivative of ln, the ln is gone. Because it's always, like in typical things, if you had ln of x, and you're taking the derivative, it's 1 over x. There's no ln anymore. Okay? All right, so we're good? All right. (17 to the x). What's the rule for that? That's one of those first rules we got. That was the a to the u.
The log of 17
Yes. Yes. So you've got this to start with. You've got 17 to the x times ln of 17. And what's the derivative of x? 1. So we don't even have to fool with that. So I think we would write it like this. Okay, derivative of a to the u. This is some number raised to a power of x, okay, or something with x. So here's the rule, and the rule says it's a to the u, which is what you're given, ln of a times u prime. So I wrote, here's a to the u, here's ln of a, because my a was 17. The derivative of this part, derivative of x is 1, so I didn't even have to write it. Is that better? Okay. All right. All right. One more like that. Y equals 7 to the square root of x. What would you do first? Rewrite? What would we rewrite it as? 7 to the x to the 1/2. I need to get rid of this guy. So, same rule. What's our derivative going to be? Okay, so we've got a to the u, ln a. Now I've got to do u prime. U prime is the derivative of x to the 1/2. So what's that? To the negative 1/2. Okay? So now we've got to just kind of clean that up. And the original answer had that in square roots, so we'll want to take that back to that. So 7 to the square root of x, ln 7, this is going to go to the bottom, so ln 7 over 2 square root of x. Is that right? Maybe we're being multiplied, so maybe that would make more sense there. See if that makes sense.
That's 2 to the square root of x, right? That was 2 times square root.
No, this one is x to the negative 1/2, which just means it's the square root of x, but on the bottom. And the 2's down there because it's 1/2. So, do you see what I'm saying, Mitchell? Okay. So is that good? You didn't get that? Okay. The rule, ma'am, is a to the u, ln a, times the derivative of u. So the derivative of this is 1/2 x to the negative 1/2. You got that? It's this part that you're confused on. So we change this back to 7 to the square root of x. ln 7, this thing's going to go on the bottom because it's negative exponent. So the 2's on the bottom, the square root of x is on the bottom. Is that better?
Can you put the 7 to the square root of x?
On the top, you could. You could.
Yeah, I'll do it later.
I didn't, but I'm sure that it should take that. All right, last one. Big hooray, right? That was a little lame, but okay. X to the 5 pi. All right. Okay, we've been doing a lot. It's 5 pi. Yep. And that's an equals. So y equals x to the 5 pi. What is that? Is that just x to a number? Are we back to regular old power derivative thing? What would the derivative be?
X to the 5 minus 1.
Would it be that?
Double hooray.
Why would I just subtract?
Do what?
Like, why would just can't subtract
It's not a rule. You could, but it would be less than exact. The reason we leave it like this, if you take some number and you subtract 1 from it, does pi really ever end? No, it goes on forever. So the only way to be exact is to say 5 pi minus 1. So when you want exact answers, you don't use an approximation for pi. So you don't really, you don't use 3.14 or anything like that. Yes, same thing with E. Yeah. All right. Is that good? Is a nice way to end?